Question 8, page 120. A smooth sphere of mass m collides obliquely with another smooth sphere of mass 2m. Okay, which is at rest. So this one is at rest, so that means this is 0 and this is 0. Okay, it's at rest. If this is 0, we know that the velocity perpendicular to the line of centres is the same before and after. So this is 0. We'll call this y. The m mass has a velocity of 8 in the I direction and 4 in the j direction, where I is along the line of centres. The m mass is then deflected through 90 degrees. Okay, so if we take this as being theta, we can see clearly here that the tan of theta is the opposite over the adjacent, so it's 4 over 8, which is a half. So theta is the angle whose tan is a half. Now, we're told that afterwards, so if we look at it, this is beforehand, so it was theta. Afterwards, it is deflected through 90 degrees. So that's a right angle. Okay, so if that's a right angle, if that's theta, this is a right angle, so this angle is 90, take away theta, this angle here. Since the whole lot is 90, this must be theta. So what we're saying is afterwards, the sphere is moving in that direction, having been deflected through an angle of 90 degrees. Okay? That means, but we already know, rather, that the tan of theta, sorry, this 4 here is preserved up here, so that's also 4, because again the velocities along perpendicular to the line of centres do not change. So this is 4 and this is theta. So if we call this x, we know that the tan of theta from here is its opposite, which is x, divided by its adjacent, which is 4. But we already know that the tan of theta is a half. So multiply both sides by 4, x is equal to 2. So we now know that this sphere afterwards ends up travelling at 2 in this direction, 4 in this direction. Okay? Now, just because we're used to dealing with it this way, I'm going to draw that as -2 in that direction. Okay? It's exactly the same as saying 2 in that direction. Okay, now we want to find y. So we can use the principle of conservation of momentum to find y. Principle of conservation of momentum, momentum before m times 8 plus 2m times 0 is equal to -2 times m plus 2my, the momentum afterwards, in the direction parallel to the line of centres. The m's divide out, and we get 8 plus 0 is equal to -2 plus 2y, so 2y is equal to 10, y is equal to 5. Okay, that means we can now put 5 in here. All right. Now they want us to find E. So the only thing we haven't used so far, Newton's experimental law says that -2 take away 5, the difference between the velocities afterwards is equal to -e times the difference between the velocities beforehand, which is 8 take away 0. -7 is equal to -8e. E is equal to 7 over 8. Okay.